the Foundation YouTube channel. Today we'll be looking at measurement of surface runoff, the dilution gauging method. So here we want to measure surface runoff and we are using the dilution gauging method. So the dilution gauging method simply, we have a stream that is flowing and at a point we want to know a stream flowing within a basin and we want to know its runoff, right, or its discharge. So we take a substance which we will call a tracer, whose concentration is known. We place it in the river or in the stream. So we place it there and it mixes up with the water and it moves, right? Then we sample at intervals to determine the concentration. We sample at intervals to obtain the concentration at various points. So I will call churnage. Okay, so when I put, let's assume that I have a substance whose concentration was, let's say, 40 milligrams per liter. After putting it at this point, I had the concentration to be 20 milligrams per liter. At this point, the concentration was, let's say, 15 grams milligrams per liter. At this point, it was, let's say, 7 milligrams per liter. At this point, it was 3 milligrams per liter. So this data that I have, I'll use it to determine the discharge of what? Of the stream. And that is what I'm going to use to find my what? My runoff, my surface runoff. Now, this method is used for rivers that are too shallow to be measured using the other means of measurement or other means of estimation of surface runoff. So this method is mostly used when the river is too shallow and also when the stream flow is not turbulent. So it is much more of a gentle flow. You get it? And streams flowing with steep gradient, that is the condition at which we use this what dilution method. Now we don't just take any substance to be our tracer. So we have conditions for our tracer. We don't you just don't you can't just go and put any substance at all if it's going to affect the ecosystem of the water body, that is the aquatic animals and the water body itself, then it cannot be used. So we have some conditions that we look out for. So first, the substance that you are going to use as your tracer should be what? Should have high solubility, meaning that it should dissolve easily in water. Then two, should not be toxic, should not be toxic to aquatic life. Then three, should be stable. The substance should be what stable. That is, it should not react, do you get it, with water. It should be non-reactive with water. Then for the substance should have low background concentration. So the river that is flowing, the substance, if we check for the concentration of the substance without putting the substance inside, the concentration of the substance within the river should be what? Low. That's what it means by low background. Then the tracer 5, I'll say that the tracer should be capable of accurate quantitative analysis in very dilute solution. So these are some conditions. Now the substance that is mostly used is bromine 32. You can use rhodamine, rhodamine and isotopes of tritium. So these are the substances that are mostly used as our tracer. Now, With these experiments, we use this relation to find the runoff, that is Qt multiplying Ct minus Cs over Cs minus C naught. Now, what is Qt? So Qt is my tracer flow rate, my tracer flow rate. Ct is my tracer concentration. Ct is my tracer concentration. Cs is my sample point concentration. Sample point concentration. That is that the various point that I took the water sample, the concentration of the tracer within it. So sample point concentration. Then C naught is my background concentration. So background concentration. Need to take note. Then my K is my stream flow rate, or what we call the discharge, and that is my what runoff. So this is how we determine it. So now let's go into the question after the explanation. Let's see how to go about it. So let's see the question. So we have a 245 milligrams per liter bromine. So that is my what? CT, right? That is my tracer concentration. My tracer concentration. And that is 245 milligram per liter of bromine. Was injected at a constant rate of 60 milliliters per second. So that is my QT. That is my tracer flow rate. Tracer, my tracer flow rate, which is what 60 milliliters, 60 milliliters per second. In a dilution gauging test performed on the stream behind the engineering auditorium, if the background concentration, that is C naught, is of bromine 32 in the stream is, so background concentration, so the background concentration is 0.05 milligram per liter, and its concentration at the sampling site downstream is 5 milligram per liters. And so that one is my SCS, sample point concentration. Sample point concentration, that is what? 5 milligrams per liter. So then I can find my runoff or my discharge or the discharge of the stream, which is given by this equation. So Ct minus Cs over minus C naught. So Q, which is Qt, which is 60 milliliters per second, multiplying Ct, which is 245 milligrams per liter, minus what? 5 milligrams per liter over Cs is what? 5, so 5 milligrams per liter minus C naught, which is 0.05 milligrams per what liter. And so I'm going to get my Q to be equal to 60 milliliters per second multiplying what? 240 milligrams per liter over 5 minus 0.05, that is what? 4.9 what? 5 milligrams per liter. So this will cancel this, right? So I'm going to get 60 by what? 240 over 4.95, and the unit to be what? Milliliters per what? Second. So let's see the after evaluating this what we get. So we have 60 multiplying 240 over 4.95, and so our discharge will be equal to 2909 point what? 0.091 milliliters per second. And so my Q will be equal to 2.90 or 2.91, I will say liters per second. As simple as that. Thank you very much for watching. The next video can be gotten from the link below. Make sure to subscribe, like, and share with your friends. Bye.